All right, we're going to work a couple of quick examples of word problems in section 7.2. Because they're word problems, I didn't have the problems copied down on a piece of paper, so I'm just reading them out of the book here. This one says a biologist is culturing bacteria in a large petri dish. She begins with 1,000 bacteria. So I'm going to write down the important stuff over here on my piece of paper. She starts with 1,000 bacteria. Okay. And then supply sufficient food so that the first 5 hours the bacteria population grows exponentially. So if the population doubles every hour, how many bacteria are there 2.5 hours after she begins? Okay. Now on these problems, they're typically going to give you a formula that looks like this. Notice that the t is up in the exponent. It's an exponential formula, and this thing is growing exponentially. So let's write this down. Let's explain what all these things mean. It's p of t, is equal to p sub 0, a to the t power. Now what these letters stand for, the population after so much time, after 2 hours, after 4 hours, whatever you plug in for t, that's going to tell you the population at that time. P with a sub 0 means the population when you started, which in this case is going to be 1,000. We started with 1,000 bacteria. The t, of course, is time, and we don't know because we know what that is. It says how many bacteria will there be after 2.5 hours. So we know we're going to put 2.5 up there in for the time. This a is the rate at which it's growing. Since they said it's doubling, that means it's multiplying by 2s. It's going 2, then 4, then 8, and then 16, and keeps doubling like that. So this will tell us the population after 2.5 hours. Okay? So on your calculator, you'll simply say 2 to the 2.5 power, do your exponent first, then multiply that times 1,000, and that will end up giving you 5,657. That tells you how many bacteria are there after 2.5 hours.